Greetings, netizens. Our planet is filled with water, with an average depth of its oceans reaching almost 4 kilometers. The oceans represent 71% of the surface of our planet and contain 97% of all the water on Earth. This crucial factor has played a significant role in the development of life. No other planet in the solar system has as much water as Earth. This leads us to question why there is so much water here. Today, I will discuss the most probable origin of water and its potential importance on other worlds and the beings that inhabit them. Water is an essential and vital component on our planet, supporting numerous forms of life. Although we, as terrestrial beings, are now adapted to life on land, our origins trace back to the water of those oceans around 4 billion years ago, where the essential molecules of life began to form. It is astonishing to note that our bodies, just like the oceans, are composed of approximately 70% water, leaving no doubt that we have emerged from the water found on Earth. Although that water may have come from elsewhere, understanding where it comes from will be important to determine if there is life on other worlds. There are several hypotheses regarding how such a large amount of water may have originated on our planet. One hypothesis suggests that the origin of water could be from icy bodies, such as comets, that impacted Earth over millions of years. Comets are objects made of ice and rock that orbit the Sun in highly eccentric paths. About 4 billion years ago, during a period known as the Late Heavy Bombardment, the solar system was chaotic, and objects collided with each other. It is believed that Earth was bombarded with comets during that time, leading to the formation of the oceans. However, it would require an immense number of comets to create the oceans as we know them. Studies of hydrogen isotopes in comet water, specifically deuterium, have shown that they are heavier than those found on Earth's surface. This suggests that comets may not have been the primary source of our water, since their water is heavier than what we find on our planet. This leads us to consider that other bodies carrying more water, such as the main asteroid belt, might have been responsible. Another interesting hypothesis suggests that not only comets but also other objects in the main asteroid belt, located between Mars and Jupiter in our solar system, may contain significant amounts of water. It is believed that there are objects in this belt that are hybrids between asteroids and comets, and they possess substantial amounts of water, exhibiting properties of both comets and asteroids. Around 15 of these objects have been detected and are referred to as asteroid belt comets. One of the examples of this type is the asteroid 24 Themis, which contains a large amount of ice. Studies have been conducted in the oceans to verify the validity of this hypothesis and if the composition of these objects corresponds to that of our oceans. The results of isotopes in carbonaceous chondrites only weakly support the objects from the main asteroid belt having a terrestrial origin. Some Japanese scientists argue that the water cannot have come from outside, it must have originated here on Earth. According to this hypothesis, the Earth was already composed of hydrogen, and its reaction with the Earth's mantle, composed of silicates and other elements, gradually formed the lakes and oceans we know today. However, many believe that there couldn't have been significant amounts of free hydrogen over 4 billion years ago, and due to the high temperatures at the time, any ocean would have evaporated. Another variant of this theory involves volcanoes expelling large amounts of water in the form of gas into the atmosphere, which then turned into clouds and rain, filling the planet with liquid over millions of years, repeating the cycle over and over again. The water came from various sources, and there is a possibility that it came from Earth and other bodies in the solar system. It should be something coherent if we consider the evidence we have. However, it still doesn't explain how Earth has more water than other planets and satellites in our system, which is the subject of controversy. According to my personal hypothesis about the origin of water, we don't exactly know how a solar system forms, although we have some idea of it. The universe contains a vast amount of water. The H2O molecule is one of the most abundant in the universe. Our universe is young and still has a lot of hydrogen, which is the most abundant element. The rest of the elements are formed by ancient stars. Oxygen is the second most abundant element after helium, so it is relatively easy for hydrogen and oxygen molecules to combine in many other places to form water. Cosmic dust surrounding stars can host water molecules, forming molecular clouds and transporting them to other places in the cosmos. The origin of water on our planet comes from stars, particularly older stars than the Sun. We have detected water everywhere in the universe, but detecting water outside the solar system is not easy. We have to capture it by analyzing light and radiation in the electromagnetic spectrum to provide us with details. Water emits radio waves with a specific wavelength of 1.35 centimeters, which can be captured by radio telescopes. This is one of the ways we can detect water on other worlds. We are in the Taurus molecular cloud, which could fill the Earth's oceans 2,000 times. Water accumulates in gas and dust nebulae where stars are formed. Due to gravity and mass accumulation, a protostar is formed, triggering nuclear reactions, and thus our Sun appeared. In the early stages of the solar system, we can imagine a disk filled with water molecules. This primordial cloud was partly composed of gaseous water closer to the Sun and icy water farther away. The inner planets like Mercury couldn't retain that water due to lack of atmosphere, and solar winds swept away the water vapor from their surfaces. Venus, which initially had as much water as Earth, lost it due to solar activity, where water molecules split and hydrogen escaped into space. The distant gas giants could only retain some water in their moons, like Europa, Titan, and Enceladus, in the form of ice. Beyond that, the dust and water ice from the early solar system formed comets. Only Earth retained significant amounts of water, partially because it had an atmosphere and pressure early on, allowing it to hold a large amount of liquid. This water emerged on the surface through volcanoes and geysers, forming clouds. Unlike other bodies like Mercury and the Moon, which let water escape into space in vapor form. Additionally, a large number of water-containing objects bombarded the planets. It is believed that the inner planets, such as Mars, Earth, Venus, and Mercury, received the most impacts due to their proximity to the Sun. Mars could have had oceans like Earth, but its low gravity and loss of its magnetic field caused much of the water to evaporate. However, Mars still retains a significant amount of water underground. If Mars had Earth-like pressure, it would likely be filled with oceans and rivers. Water was the precursor of life, and it is possible that we ourselves came aboard a comet or asteroid and contaminated the primordial oceans. What is certain is that both us and water were born in the hearts of stars that existed before the Sun. Water may be common in other parts of the universe, provided the ideal conditions are met, as we have discussed, an ideal distance from the star, an atmosphere, and pressure to retain the water, and, of course, a planetary system rich in water. Water has been detected on other planets outside the solar system. One example is the exoplanet K2-18b, which is a little over twice the diameter of Earth. It has been found that 50% of the planet could be water, and its temperature would range between 0 and 40 degrees Celsius. K2-18b is a super-Earth orbiting a red dwarf every 33 days. This and many other planets may be abundant in the universe, and there might even be ocean planets, entirely covered in water or with small islands, where oceanic life, including intelligent life, could exist. However, the presence of intelligence does not necessarily mean they possess technological capabilities. For example, dolphins are intelligent creatures but lack the ability to manipulate tools or alter their environment. Water is quite common in the universe and can be found everywhere. Significant amounts of water have been confirmed in protoplanetary disks similar to our solar system. Stars contain 85% of the water in the universe, and it is generally found in gaseous or icy form due to specific temperature and pressure conditions. It only requires a suitable environment to accommodate and retain it in liquid form. In the centers of many galaxies, there is a substantial amount of water vapor due to intense star formation and collisions between clouds. For instance, a hyperluminous quasar located 12 billion light-years away has a water reserve about 140 trillion times the total volume of Earth's oceans, an immense quantity. This means that the universe already contained a lot of water in the past and has been transported in nebulae and from one star to another. The universe has its own water cycle. Here we see a red giant star expelling gas into the interstellar medium. Its radiation will destroy water molecules that might exist, dissociating the atoms into hydrogen and oxygen. These atoms will then recombine to form molecular clouds containing various elements, including water. The universal machinery constantly renews itself, combining and transporting water molecules throughout the cosmos. This is not something strange. The recombination and evolution of atoms into more complex molecules is a common occurrence in the universe. On Earth, conditions were favorable for having water in its liquid state, to the extent that Earth is nearly an aquatic world, which is extraordinary compared to other planets in the solar system. However, on a universal scale, this is not unusual. If you like this video, give it a like, don't forget to subscribe, share it on social media, and leave your comments.